Microsoft Internet Security and Acceleration Server 2006, or ISA Server 2006, is the latest version of Microsoft's software-based firewall and caching server. Now, for those of you listening that have been around for a while, you might recall that Microsoft had a product called Proxy Server. Now, its job was to provide caching services so that companies could speed up web browsing and make delivering web pages and data to the end user much quicker. So this proxy server component eventually found its way into the product that we see today called ISA Server, and that's really where this acceleration part of the name comes from. This caching speeds things up or accelerates things along if you prefer that terminology. Now, the second part of this title is the Internet Security part, and this refers to the firewall part of ISA Server. And if you don't know what a firewall is, well, it's probably likely that you're watching the wrong video training course right now. You probably should have an idea of what a firewall is by now, but if you don't, well, we're going to go easy on you anyway. A firewall is simply a piece of dedicated hardware, or it's software, that's designed to keep the bad guys out, and the good guys, well, they're often free to work inside your network and go out onto the internet, but in a controlled and secure manner. So let's talk a little bit about what these two things are in more detail, since it's important that you understand what these proxy or caching capabilities really mean for you in the real world, and of course, what a firewall's used for as well. Now, for those of you that already understand what these things are all about, you could probably skip this part and move on to the next section where we're going to talk about the requirements for ISA Server 2006. And if that doesn't interest you, well, you can get stuck into installing ISA Server. You can then move on to the next video. All right, so let's take a look at this acceleration part or caching part of ISA Server. Let's see how it works. So let's say we've got a user here. There's our user. And they're going to fire up a copy of Internet Explorer. Well, it doesn't actually have to be Internet Explorer. It could technically be any web browser. And let's say this user wants to visit a random website. Let's say they want to go to www.winstructor.com. Now, because this user's browser would be configured to use the company's proxy server, or rather the ISA server, the request for this Winstructor homepage is first going to head off to the ISA server. And that's my attempt there at drawing a firewall. I'll go with that. So this ISA server, the first thing it's going to do, it's going to receive the user's request, and it's going to check its own cache just to see if it's previously been to winstructor.com. Now, if this is the very first visit to winstructor.com, then it isn't going to have any copy of the home page stored in its cache here. So it's going to have to head off to the internet and get a copy of the page. We'll just draw, we'll call this the internet here, and we'll assume for the sake of the argument that this is the server for Winstructor. So our ISA server here, in this case, is going to head off across the internet to www.winstructor.com. It's going to do this on behalf of our user, and it's going to fetch a copy of the page along with any graphics and videos and text and whatever data is required to get that page. So the Winstructor website, it's going to respond to that request, and it'll send a copy of this page along with all of the data it requires to the ISA server. Now, the ISA server is going to take this data. It's going to save a copy of it right here in its own cache, and then it'll return the page to our user's computer, and then the user, of course, is going to be able to view the web page in their browser. Now, as you can imagine, for most websites, this is a pretty quick procedure. Normally, it only takes a few seconds to get that page, depending on the speed of your connection and the connection at the website that you're visiting. So, the end result here is that our user now has his data, and of course, he's rather happy. So what happens when we have subsequent users? Well, along comes another user. Let's just pop another user over here. And let's call this guy Lucas. And Lucas decides he wants to go to winstructor.com. So his request is also going to head over to the ISA server. The first thing the ISA server is going to do is check its cache here to see if it has a copy of the page that Lucas has just requested. Now this time, the ISIS server discovers that it does in fact have a recent copy of the default page because this user here went there a moment ago. So our ISIS server, instead of going back over the internet, it can just send this page directly back to Lucas. Now this is good for a couple of reasons. First of all, it should be quicker for Lucas to be able to access the site, since the page is now being retrieved from a cache on our ISIS server, which of course lives on our local area network. And that has to be faster than having all of those packets being trafficked out all over the internet each time. Now it also means that we're going to save bandwidth, because the page is being retrieved from the ISIS server. We don't need to go out on the internet each time, and that of course is saving money. So we're saving time and we're saving money. Two things which I'll bet every one of you listening to this video right now can't get enough of. Now obviously this is a simplified example here, and we've only just summarized this feature here with just these two users, but it potentially means we've saved 50% of bandwidth, because we only had to get this data here once. But what happens if we had, say, 500 users, and all of them wanted to head off to Winstructor to download the files that we cache locally? Well, we're dealing with video files, of course, so that's going to mean some pretty big bandwidth savings. Now the other, and probably the more important feature of ISIS server, I'd guess, would be the firewall. Now Firewall, in the case of ISIS server, is a software program that we can configure to either allow or deny outgoing requests or incoming requests for our data. So here, let's say we've got a bunch of PCs, and this is a representation here of our local network, our internal network, and of course this is going to be connected to the internet. Now from here we'd want to contact other websites and other hosts out here on the internet, and given the right configuration, some hosts might even be allowed to contact devices inside our network. Now these could be things like VPN clients, or maybe just regular users accessing, say, our website or other hosts. Now protecting us from the bad guys out here on the internet is our ISIS server, or more specifically it's the firewall part of the ISIS server. And you'll note that when we draw these diagrams, it's always this brick wall you see here that we use to represent the firewall. So this is typically where our firewall would sit. Okay, so let's take our user Lucas again. Let's say that Lucas wants to go to the Winstructor website. We'll say that's the web server there for Winstructor. So as we know, Lucas's request for the page at the Winstructor website, the first thing it's going to do is hit our ISIS server. Now at this point, depending on the rules that we have set up here at our ISIS server, that request is either going to be allowed outside the network and then sent on to the website, or it could be denied and then Lucas can't get to the page. Now conversely, if we maintained our own website here, and we'll say that's www.mysite.com, and we've got an external user out here on the internet, and this external user is requesting a copy of our default page from our web server. Now we could also, depending on our rules again set here at the firewall, we could either allow that request to go through and so he can retrieve the page, or of course we could deny it based on the rules we've set. Now when you're planning your ISIS server deployment, there's a lot of different scenarios that you might want to consider, but there is no one-size-fits-all solution. So what I'm going to do here next is I'm going to run through some of the common configurations that you're likely to use with ISIS server, and then you can modify these to suit your own environment. Now one of the options you have for your ISIS server is that of a caching-only server. Now, although it's probably not a likely scenario, you could just use your ISIS server, and in this case we'll say that this box here is our ISIS server. You could use it to cache data and not provide any sort of firewall duties. Now it's only acting as a simple proxy server to cache data to make these future requests for the same data much quicker. Now since it's not acting as a firewall. This means it's the only scenario where you can get by with a single network card inside your ISA server. Now do realize though, if you're not using your ISA server to provide any firewall capabilities, you will need to have some other machine providing your firewall capabilities in your network. So if you run with this caching only server here, you'll probably want to have another firewall in place, something like a Checkpoint or a Cisco Pix or something like that. Now another reason why you probably wouldn't run with this sort of configuration is it's pretty expensive, because you're wasting money really by only using ISA server as a caching only server, and then you're paying for another firewall when ISA server is a pretty good firewall in its own right. But hey, I'm only presenting what you can do here. Although you most likely won't build a caching only server, it is something you can do if that's what you want. Now the next scenario we're going to look at is what we would call the Internet Edge scenario, if I can spell edge, E-D-G-E, that's correct. And this is popular in smaller companies when we have a single office solution because it's pretty cheap and it's very effective. Now this is your typical one box fits all type solution. So in a scenario like this, you'd normally have your company network sitting behind your ISA server, which is directly connected to the internet through a router. And for small companies, that's often going to be a DSL router or a cable modem, and everything is simply just passed through that router directly to the ISA server, and this is going to provide all of your firewall and caching capabilities. So the ISA server in this scenario is designed to protect our internal company network from attacks that are coming from the internet, as you'd typically expect any firewall to do. But we can also configure the ISA server to allow internet users to come through our network to access internal resources such as a web server. And we'd make these sorts of services available by publishing these servers through our ISA server. And publishing servers is an important part of ISA server, so we will be talking about publishing servers later on in these videos. Now obviously our ISA server could also be used as a caching server as well. So if one of the users here, will grab our guy Lucas there again, if Lucas here from our internal network is requesting a page from a web server out here on the internet, our ISA server of course is going to cache that page locally and then send that page back to our user. And of course any other attempts to get that same page is just going to be fed from the cache on the ISA server rather than having to go back out to the internet again, saving bandwidth and of course making things faster overall. The next scenario we're going to talk about here is what we refer to as the backend scenario. And this is most likely going to be the sort of scenario deployed within medium to large companies, and probably the one that you guys listening to this video will be using as well. Now, unlike the edge firewall scenario we saw a moment ago, with small companies resorting to a DSL or a cable modem, in larger companies you're going to see much faster connections. Now this brings up another point. Even though these videos are all about using ISA server as a firewall in your organization, if you're using a back-end firewall scenario like you see here, then you should configure your router to drop any unwanted packets right there at the first entry point to your network, because you'll find that your router is really good at performing packet filtering really fast, and handling certain traffic here alleviates the load on the ISA server itself so it can perform better and do what it does best. So if you have particular ports or particular IP addresses that you just don't want coming into your network, configure your router to drop them rather than configuring that at the ISA server. So our ISA server in this scenario will be used for its firewall capabilities and server publishing, so we can provide services to people out on the internet, and of course it's going to be used as a caching server as well. So this brings us to another point. In larger deployments, you're very likely to see the inclusion of a demilitarized zone or a DMZ. So what we currently have here right now is we've got our back-end design. We have our ISA server here, and it's going to have two network cards. It's going to have one here, and these two network cards are going to provide routing of packets between our internet-facing router and our internal network. And whilst this sort of scenario offers good security, when we publish internal servers, we open them up to people out on the internet, and that of course means opening up the risk of attacks as well. So, by adding a third network card here, we could now create a totally separate network which we call the DMZ, or a demilitarized zone. And it's this DMZ that now allows us to take the servers that we want people outside of our network, guys from the internet, to access. We can put them inside our new network, so we'll say this is our web server here, and that won't compromise the security of our internal network. Now the final scenario we'll take a look at here would be for a branch office, and this would very likely be an extension of the back-end server deployment that we just looked at. So here, in our branch office scenario, you're likely to have ISA server connected just like we've already talked about. But we'll also have one or more branch offices to factor into our security design. Now in most cases nowadays, you're going to have these branch offices connected using VPN connections over the internet, which is far less expensive than dedicated WAN links. So by configuring an ISA server out at each remote branch, these sites can communicate with each other over the internet using a VPN connection. And this is important because not only is the actual cost of the connection so much cheaper, but the traffic is encrypted for better security. So by using ISA server in this way with our branch offices, we still get great security. We're still able to communicate freely, but it's all at a much lower cost than it would be if we had to have dedicated links. Now before we begin the actual installation of ISA server, the first thing we should do now is plan ahead. You know, ISA server isn't very difficult to deploy, but you should think about how you're going to deploy it and how ISA server should be configured to work in your environment. So do you want ISA server to secure incoming connections to your network? Probably yes. Do you want to lock down outgoing connections to prevent people from visiting certain locations on the internet? I'd probably say yes to that one as well. Now we don't always want users just heading off blindly to any site. There are some that we're probably going to want to block. Now would you like ISA server to provide local caching services to speed up internet access for our users? Sure, why not? So what we're really getting at here is, do you want ISA server to be a firewall? Or do you want it to be a caching server? Or do you want it to be both? Now in most cases, we'll be configuring it to do both of these things. Now we'll also need to give consideration to how many users are going to be using our ISA server and whether these connections are coming from outside into our network or they're coming from inside and going out. Now this is important to size up our requirements, so I will talk about it more when we talk about the hardware requirements. Now you'll also need to decide whether this ISA server is going to be installed as a standalone ISA server or as a member of an array. Now in almost all cases I'd recommend the array, but in order to create arrays you will need to buy the Enterprise Edition of ISA server, which is more expensive than the Standard Edition. So if you do have the Enterprise Edition at your disposal, I'd strongly recommend going with the array. You see, the Standard Edition of ISA server does have a few limitations that the Enterprise Edition doesn't have. Firstly, the Standard Edition is only able to be configured as a standalone server and not a member of an array, not like our Enterprise Edition can here. Now our standalone edition is also limited to running on up to 4 CPUs and 2 gigabytes of RAM, whereas the Enterprise Edition, it really doesn't have any hardware limits, and obviously the more CPUs, the faster your ISA server will be able to perform and the more users you're going to be able to serve. But bear in mind though that regardless of whether you're using the Standard Edition or the Enterprise Edition of ISA server, Microsoft license ISA server per CPU, so make sure you factor this into the price of deploying your ISA server, especially if you're planning on running it on a multiple CPU box. Now also consider if you're going to use a single processor box, you might get better performance out of 2 single CPU machines than you would get out of 1 dual CPU machine. Now finally, our standard edition here of ISA server obviously is only limited to creating local policies. And because a standalone server can't be part of an array, if you do have multiple ISA servers, then you'll need to manage each one of them, each standalone ISA server, independently, and you'll need to configure and manage them separately. So that means if you purchase the standard edition of ISA server and you've got, say, 5 ISA servers in your environment, you'll need to manage 5 ISA servers separately. Now, on the other hand, this Enterprise Edition, it's a little more expensive, but it does integrate with Active Directory, and that allows us to centralize our policies by setting up an array. And you can just configure the array once, and then all of those settings will cover all of the ISA servers in your array. So it's really easy to manage multiple servers from a single location. Now you'll also need to consider the hardware that you want to run your ISA server on. Can you dedicate a server to ISA server, or is your ISA server going to coexist with other applications? Now hopefully you're serious about security and you're going to dedicate a server just for ISA server. You really don't want other applications running on your ISA server. Although there's technically nothing stopping you from doing that, you really just want ISA on that server though, and nothing else. Now the minimum requirements, the hardware requirements for ISA Server 2006, they're really not that high. At minimum, you're going to need a 733 MHz CPU. You'll need 512 megabytes of RAM, and you'll need Windows 2003 with Service Pack 1, or you'll want Windows 2003 R2. Now you're also going to need your hard disk formatted with NTFS. You'll need around 150 megabytes of free hard disk space, and if you plan on using the caching features of ISA Server, then you're going to need more space for that as well. Alright, well, let's be real here. These minimum specifications are pretty pathetic. I mean, a 733 megahertz CPU, 512 meg of RAM, 150 meg hard disk? I mean, come on. If you can't exceed these minimum hardware requirements anyway, there's something wrong with you. So go out and buy something new. Now, anything new really is going to be a pretty good ISA server, as even the lowest spec new machine is going to totally blow these minimums out of the water. So at least as far as hardware goes, anything that's been purchased in the last couple of years should absolutely flog these minimums. Now you also will need 2 NICs, one to point to your internal network and the other to point externally. Now if you prefer, one card's going to connect out to the internet and the other will be connecting to your internal LAN. Now that is, unless of course you're installing a caching only server, which isn't that likely, but if that's the case, then you only need one network card. Again, unlikely, so plan on requiring 2 network cards. Now, if you are going to be using your ISA server for caching though, then you will need to consider that when you size up the server that you're going to build. Now I'll admit up front, I couldn't find any data from Microsoft regarding the additional hardware requirements for a specific number of users, but I could find that data for ISA Server 2004. So what I'm going to do is I'm just going to regurgitate those requirements just so you guys have something to go by. But do be aware what I'm about to say is for ISA Server 2004, not 2006, so the actual numbers might differ slightly. Alright, well, with that disclaimer out of the way, if you are going to be running a caching server, the more RAM you have, the better your ISA server is going to perform, as it will be able to cache more information without having to retrieve it from disk. So RAM is definitely your #1 priority. And with prices at an all-time low, it's cheap anyway, 2 gig, 4 gig, 8 gig, it's all pretty cheap. So the disk space requirements for a caching-only server is going to depend on how many users you want to connect to your ISA server. Now, Microsoft recommend that you have about 4 gig of hard disk space for your cache for up to 500 users. And you'll need around 10 gig of space for anywhere between 500 to 1,000 users. Now, if you have more than 1,000 users that are connecting to ISA server, Microsoft still recommend 10 gig, but for every 1,000 plus users, Microsoft recommend that you add a new ISA server. So what Microsoft is saying is, if you have 1,000 users, you should go with at least 10 gig worth of space, and that should provide sufficient space for your cache. Now, if you have 2,000 users, then you're going to need 2 ISA servers, each with 10 gig of space. Now, in most companies though, except for the really, really large ones, a single ISA server is generally going to be enough. Now, since hard disks are much larger than these requirements we've spoken about, disk space isn't going to be a problem at all. But that does beg one question. Should you use RAID? Well, that's certainly up for debate. For the web cache, you really don't need fault tolerance in my opinion, because the cache isn't worth backing up and saving, because you can easily repopulate it when the disk needs to be replaced. So RAID for the web cache would be no, unless you're running RAID 0 for performance and not RAID for fault tolerance, which is only going to slow things down. But RAIDing the system drive for the ISA server, well, that's a whole nother story, and that I would certainly consider. Now, the one final point I should mention, and we have sort of talked about this already, but if you would like to run ISA server in an array, you'll also need to have Active Directory running in your domain, and arrays require the Enterprise Edition of ISA Server 2006, which we did indicate is more expensive. Okay, well, these requirements that we've talked about here in this video, these are the minimum requirements. So it's unlikely that even an old server isn't going to exceed these requirements here. And given today's prices of hardware, you'll find that even a low-end server with probably 4 times the minimum specifications required isn't even going to set you back much money. And don't forget, your firewall is one of the most important servers in your network. Sure, you can get away with running it on an old piece of junk, but the more CPU, RAM and hard disk space you can throw at it, the better it's going to perform. So in this video, we've talked about the security and acceleration features of ISA server. So now you should be able to understand what a caching server is and how it helps you speed up internet access, and how the firewall component of ISA server can secure your internal network from attackers, as well as make some specialized servers like web servers available to external users. We also talked about the hardware requirements for ISA server, which are really, really low, and the basic differences between the two versions, Standard and Enterprise. Now, we also talked about the different scenarios in which you can deploy ISA server, and in most cases, you'll be dealing with a back-end deployment with a DMZ for your internet-facing servers. So we hope you've enjoyed this video, and would like to thank you for watching.